Welcome to Summarize Science, where we break down complex research into simple terms. Today, we're looking at a paper that tackles one of the biggest problems in artificial intelligence: genuine understanding. Current AI is great at matching patterns, like Kepler describing planetary orbits, but it can't explain the underlying why, like Newton's theory of gravity. This paper proposes a new theory called the resonance principle to explain how our brains achieve this deeper understanding. The core idea is that understanding isn't like a computer running code. Instead, it's an emergent property of the brain's physical structure, which acts like a network of connected oscillators, or tiny vibrating strings. The theory posits that when you have a moment of understanding, your brain isn't just processing data, it's physically snapping into a stable, synchronized resonant state. Think of it like striking a bell. The recognition of a cause-and-effect pattern makes the entire network ring in harmony. To test this, the researchers analyzed brainwave data from people doing a simple recognition task. They measured brain activity in two ways: the standard voltage spike, known as an ERP, and a special measure of how in sync the brainwaves were across the whole brain, which they call resonance. And here's where it gets fascinating. When they looked at the average activity over time, the two signals, resonance and voltage, looked completely unrelated. You can see it in this graph. The purple resonance line has a clear structure, while the red voltage line just looks like noise. This proves they are measuring two genuinely distinct things happening in the brain. But the real discovery came when they looked at each individual aha moment, one trial at a time. This scatter plot shows that on any given trial, the stronger the resonance, the bigger the resulting voltage spike. The correlation was incredibly strong and statistically significant. It suggests that while the two signals are globally different, the resonance is a powerful predictor of the neural output we can measure. So, what does this all mean? The researchers interpret this to mean that phase synchronization, or resonance, is a hidden, primary mechanism that coordinates brain activity. The famous P300 brainwave that neuroscientists often study isn't the event itself, but rather the byproduct, or symptom, of this underlying resonance event. Essentially, brainwaves aren't just a side effect of thinking, they are the physical form of the computation itself. Let's recap the important points. The paper provides evidence for the resonance principle, arguing that true understanding emerges from physical synchronization in the brain, not just logical calculation. Researchers found that while this resonance signal is statistically independent from the standard voltage signal over time, it strongly predicts the voltage spike on a moment-to-moment basis. This suggests resonance is the cause, and the measurable brain spike is the effect. For the future, this implies that to create truly intelligent AI, we might need to build hardware that is physically noisy and can resonate, moving beyond today's purely digital computers. It's a fundamental shift in how we might think about both cognition and computation. Thanks for watching Summarize Science.